So let's start this video by solving this practice programming task here. So construct a function called distance that takes 2-point objects as arguments and returns the Euclidean distance between them. So note in this case we need to create both the point class as well as the distance function to use it. Now the Euclidean distance function ends up being just one of those things you'll end up using a lot in computer science, the distance between two things in space. So let's just create this code, shall we? Again, I recommend pausing this video, trying it out on your own, and then coming back and watching how we create it together. So let's call this point.py. And start by creating, let's start with our usage, I suppose. So down here, way at the bottom, we're going to say def main. We're going to do, we're going to create 2 points. So say something like home equals the point 10, 20, whatever that means, and work equals the point 50, 50. So now, what is the distance between these two things? So we'll print distance from home to work. Okay, so we need two things here. We need def distance for that to work. It has a P1 and a P2, 2 different points. And for now, we're just going to say pass. We'll fill that in a little bit later. But first, we need to create a point class. So to create the point class, we're going to have to say class point. Okay, and this represents the point class itself. So say here, a point represents a two-dimensional point in space. Okay, so now to create a point class, we need to have the initializer. So let's create a real simple point class here. Def underscore underscore init underscore underscore. Then we need self. And because it's a 2D point, we need an x and a y. And in this case, we just need to store those. So self.x equals x and self.y equals y. And that should be everything. Okay. Now, the Euclidean distance equation is the square root of the difference of the x and y axes, each squared. So first things first, we need to take the 2 points and get their relative difference. So say def distance here. So we have P1 and P2 are our 2 points. And these points are not very complex objects. They're just storage for 2 pieces of information themselves. So it's almost as though we passed in 4 pieces of information into this function, but they're paired together into these objects. So first things first, we need the difference along the x-axis. So we'll call that xdiff equals p1.x minus p2.x. And then we need the difference along the y-axis, so ydiff equals p1.y minus p2.y. Okay. So that gives those two differences. Now I need to square both of those differences. So we have xdiff squared. We have ydiff is squared as well, so ydiff squared. And then we add those two differences together, and then square root the whole thing together. So math.sqrt. Okay. And that's the final result. So we'll return math squared all of that. Okay. Just like that. So let's try this out, see if we get our answer. Python, this is point.py. Okay, so didn't crash, that's a good start, but it also didn't do anything because we didn't run anything. So let's run main, try again, and we get a distance of 50. And I'll leave you to manually figure out if that's the correct answer, but I believe it is. So let's use this example now to explain one last concept from this chapter, magic methods. So in order to work with common operators, Python objects are allowed to implement what are known as magic methods. This is Python's name, not mine. Now, magic methods are effectively a way of creating specialized methods that operate under default operations or default operators. So for example, if we want to add 2 objects together, we can implement the underscore underscore add method. And that will, if we take point 1 and point 2 and add them together, that will run this method. Okay, so it's just a translation between the symbols that we're used to using and the internal definition that Python needs to use to create these methods. So let's start with this string method here. So underscore underscore str and then self. And this is how we can represent our object as a string. So for example, if I wanted to say something a little bit more involved here, like the distance between quote plus str home and plus str work is, and then print out the distance here, which is a number. Okay. This should work, but it won't be very good. So let's run it. What did I do wrong here? Invalid syntax. I missed a plus. There it is. Okay, so this works, but it's not the most useful. So the distance between, and then this is the default string representation of a point object. So __ main represents the method, or sorry, the file that we're running with Python. So when I said point.py and class point is defined in point.py, then we get main.point. And that's to distinguish between, for example, if we had imported something from math, if math had any objects, it would say math.point, for example. Okay. So the main.point object at, and then here's the address representing the first point object that we called home, and then the second object here, notice it's a slightly different address, F0 instead of D0 at the end, otherwise very similar, so they're stored near each other in memory. So these represent the location in memory of that point object, so the X and Y attributes are stored inside, or as Python will keep track of them. So when we want to print out our objects, the default string representation of the object is to tell us where that point thing is, where that point class is defined, and where the actual object is stored. So not the most useful, not the most humanly useful definition. But what we can do is add in a magic method, def __str__, and then self because it's a method of this object. Now, what we can do for string is print out something a little bit more natural. So we could just return a string. So let's return a string for a point. Point normally looks something like, if we have x comma y, I would say something like x comma y like that. So let's do that for this. We'll say f with squiggly self.x, comma, squiggly self.y. Okay. So with f strings, that's going to translate this into bracket, the value for x, comma, the value for y, bracket. So it's going to return an actual string that has the values represented in that string, and that's going to be returned here. So now when we say string of home, it's going to call this special method here. So let's save this, and off we go. 1020 and 5050. So it's a much easier to read output here. So the distance between 1020 and 5050 is 50. Okay, so we can see all of that in one spot. So any object that you want to have a more natural expression, if you're going to be printing those objects more often, you can put information that's useful when printed into the str magic method here. But that's not all we can do with magic methods. We can, for example, do equality or comparisons with magic methods. So let's do an equality operation for our point class. So by default, as we've seen, two objects are only equal if they're the same object. So using this equals equals operation between two objects normally is just asking object 1 is object 2. But for many different types of objects, it makes sense to have an equality comparison rather than having everything be identity comparison, right? We could create 2 points that are at the same spot in space, so those should be considered equal points, even if they're stored as separate entities. So we can do that by implementing the def __eq__ method. So in this case, we need self, as we always do, but in order to do the comparison, we also need an other. So equality is a binary comparison, it takes in 2 things. So self is the default name for that, and other is sort of the conventional name for another object of this type. So self represents a point object, other should as well. So let's compare those 2 things. So equality between 2 points should just be that their x and y values are the same. So we could say return self.x equals other.x and self.y equals other.y. Okay. So now if they have the same x object, sorry, the same x location, the same y location, then for all intents and purposes, they're considered the same point. So we can compare this, for example. Let's just come down here, create some new points here. So P equals, say, a point from 1 to 2. Q equals, let's say, a point from also 1 to 2. And let's ask, are they the same? So if P equals Q, then print P and Q are equal. Else print P and Q are not equal. Okay, so here is where we're going to be using that new method. So the equals operation takes in P as self and Q as other, and then we'll just compare to see do they have the same value. So that needs to return true or false because the equality operator is expected to return true or false. So we have a Boolean comparison here, a combination with and. So return, is this true and is that true? Should return true or false. Are they the same element? Here we go. In this case, P and Q are equal, and we can make a quick change here, change that to a 3. And now they're considered not equal. So they're value comparison instead of the default identity comparison. Let's do one more of these methods. So let's do def underscore add between self and other. So this is used when we want to use the addition operator, the plus symbol. So this is going to return a new point that's at the combined x and y coordinates of both inputs. So we'll return point self.x plus other.x, comma, self.y plus other.y. So we'll make one brand new point that takes the x of both of these elements and adds them together, the y of both these elements and adds them together, and returns that. So we take 2 points, we add them together, and then we get a point further along on the plane. So let's see this for usage. We can, let's call it P3 equals, we call them P plus Q, yeah, sure. P and Q then. And then print P3. So this plus symbol takes in 2 points now. Normally it would just give us an error to say we can't add 2 points because there's nothing implemented to do so. But now that we've said when we're adding 2 points, we have a method. So P becomes self, other becomes Q, and we just add together their x and y coordinates, returning a new point, which we store as P3. So when we print P3, it actually jumps up and uses our other magic method to print those new values. There we go. So P and Q are not equal, but 1 and 1 is 2, 2 and 3 is 5, so we have a new point at 2, 5. Now notice it's kind of important that, specifically with the add method at least, that the closure property be implemented here. So the closure property says that the outputs of a function should be in the same set as the inputs, where the set here means the set of all possible points, which is to say the input type should be the same as the output type, which means we can do something like P4 equals P plus Q plus P3, and I can print P4. So this now says take this addition, get a point back, and then add that point to P3. So do that addition afterward. So the output of this operation can be used as the input to subsequent addition operations. Save, run our code, and now we get one new point that added 2, 5, 1, 2, 1, 2, and 1, 3 all together to make this 4th point. So key points here, we can implement these native operations, these native operators like plus, we can even do minus if we wanted. Things like string output is very important, and comparison is another very important one as well, inside any custom built object that we had. So for example, if we want to compare 2 dogs, if 2 dogs have the same name and age, we want to call them the same, then we could do that as well. Maybe that doesn't make as much sense there. And that's the entire point here. We can customize what it means for 2 things to be equal, or what it means for 2 of our objects to be added together. Adding 2 dogs together doesn't make a whole lot of sense, so maybe that's something that you would leave blank. But printing a dog would be nice to have maybe the dog's name and age, rather than having, where's that real ugly syntax? Anyways, wherever that's gone, somewhere in our output here. It'd be nice to have very nice outputs for, let's say, our dog objects as well. Anyways, that is the end of this video, and it's also the end of this chapter, so I'm going to stop here. Next chapter, we're going to talk about simulation, and as well as picking up the idea of Pygame. So we'll see how to create graphics and simulation together. I'll talk to you then.